good everyone. How are you doing? So this is Agi from Messenger. Welcome to Jan Prime. Today we are going to be seeing episode 2 of the chemistry most repeated questions and explanatory answers for Jamb. We already did the episode 1. So the link of the episode 1 will be dropped on the comment section. So if you haven't seen it yet, you can actually see it. And this is episode 2. So I guess after watching episode 2 or in whatsoever way you actually did it, but okay, let's continue from episode 2 today. So from episode 1, we actually did from number 1 to number 10. So for this episode, we're going to run from number 11 to number 20. So let's get into it. Okay, for this number 11 question, it actually goes like this. It said, a quantity of electricity liberates 3.8 gram of silver from its salt. What mass of aluminium will be liberated from each salt by the same quantity of electricity? So if you actually see something like electricity, chemistry, notice it's actually coming from a topic called the electrolysis. So okay, let's see solutions to this question now. So in questions like this, that actually this on, okay, this gram actually give you this gram. So this gram will not give you what? Or this gram actually give you this. What the gram of this is now what? So you actually see questions like this in electrolysis and stoichiometry. So the best method I'm going to teach you guys today is the crossing method. Yeah. So I'm going to be using a whiteboard for this section. So just stay tuned. So okay, let's see the solution to this question now. So and don't forget, they actually gave you the relative molecular mass of aluminium, in the down part of the question, so as 27, and that of your silver, which is actually 108. So take note when you are dealing with electrolysis, you should note things like your monatomic element, your diatomic element, your triatomic element. Yeah, they are very, very important, because when you're actually calculating, for questions that are based on columns and the rest. So when it is actually monatomic element, you know that 1 is actually attached to it. So when it's diatomic, you know that 2 and tri, yeah, so it goes like that. So and in this question, aluminum here is actually a triatomic element. Yeah, it's 3 plus. Yeah. So and your silver is actually a monoatomic element. Yeah. So let's see solution to the question now. So he said if 108 gram of silver, so you can see the relative molecular mass of silver, which is 108, actually gives you, I told you guys that one, like something like one, like, okay, an invisible one, which actually means 1 mole. Yeah, 1 mole of silver times, note that this column is actually is a constant, which is 95600. Yeah, so if it's actually a monatomic, you say 1 times 95600. If it's a diatomic, you said 1 times, diatomic, which is, it will say 2 times 9600, and try, you say 3 times 9600. So for this monatomic element now, you already have 108. If 108 gram of silver equal to 96, then 3.6 gram will not be what? 3.6 gram will not be what? So let's see. Okay, let me teach you guys this crossing method I'm actually talking about, so you can get it. Okay, let's see on our whiteboard now. So on our whiteboard, Okay, I'm going to teach you guys the crossing method from here. So this crossing method, you can actually use it to solve questions on electrolysis, questions on stoichiometry. Yeah. So let's get into it now. So you said 108 gram of silver gives you 95600. So 3.6 gram of silver will now be equal to how many column here now? So you now cross multiply. Yeah. So cross multiplying to now be 0.6 times 9500 95600 equal to 108 times s will give you 108x. So you can take the coefficient of 108s. So that will actually give you something like 3.6 times 95600. You know that if you cancel all over 108, yeah, so that should give you your answer. But let's see it on our question. So yeah, that is it. So you can see 95600 times, okay, divided by 108. So collecting, doing everything should give you 3217 column. Yeah. So and in the question, they're asking you what mass of aluminium will be liberated. So aluminium is a triatomic element. So if the relative atomic mass of aluminium, which is 27 gram, actually gives you two. Okay, from this we actually got 286800 column is that we actually times 3. I told you guys that aluminum is actually a triatomic element. Yeah. So being a triatomic element, you can actually do something like this, which is the 3 times 95600. So that should give you 286800. Yeah. So okay, if that one actually gives you this, then x, so you're actually looking for what mass of aluminium, then equal to, so the column we actually got just now. So you can actually cross multiply as I did just now. So doing it, it will actually give you 0.30 gram. I hope you got this, which is D. This is the correct answer to the question. So let's move on to the next question. Question number 12. Okay, question number 12 actually goes like this. It said, suitable reagents for the laboratory preparation of nitrogen are. Just note, this is a question like if you actually read your nitrogen and its compound, you actually see things like this here. So it's very advisable to read it when you are reading all those non-metals and their compound. You should actually read them tips, because Jamb actually asks questions from each angles of this topic. So let's see. Okay, this is just a straightforward question. It's a suitable reagent for the laboratory preparation of nitrogen is A, yeah, which is sodium diazonitrate 3 and aluminium chloride. So you can take note. The suitable reagent for the laboratory preparation of nitrogen are the sodium diazonitrate 3 and aluminium chloride. Yeah, so A is actually the correct answer. So this is the reaction. All right, moving on to the next question. It said the number of electrons in the valence share of an element of atomic number 14 is, okay, in your periodic table, and you actually have your KLMLO share configuration. So it will tell you your first share actually take, so it's a law, yeah. Your first share actually take 2, your second share actually take 8. Okay, let's see it on our whiteboard. This is your first share, it actually take 2. And they're asking you an element with atomic number 14. Atomic number 14. So if this your first share actually take 2, your second share actually take 8. 1, 2, 3, 4, 5, 6, 7, 8. Then your third share actually take 8 too. Okay, from this you already have the first share already take 2, and the second share already take 8, which is 10. Yeah. So they are telling you okay, atomic number 14. So that is to say the valence share, like, so should be the atomos, that's the number of share on the atomos, or the number of atom on the atomos share. So it will not be left with 1, 2, 3, 4 to make 14. Yeah. So the number of valence electron, or the valence share in this element number 14, is actually 1, 2, 3, 4. Yeah, 4 is actually the correct answer, which is okay, D. Yeah, D is actually the correct answer, which is 4. Okay, I hope you got this. So let's move on to the next question, which is question number 14. So it actually goes like this. It said the volume of oxygen, what volume of oxygen will remain after reacting 8 centimeter cube of hydrogen gas with 20 centimeter cube of oxygen gas? So in this question, we are going to be using what we called the crossing method. Yeah. So the question that just goes like this: what volume of this? You're looking for volume of this, and you already give you the volume of the other. So the crossing method can be used for questions like this. Yeah, like that one, they give you the gram of this, and they ask you to calculate for the gram of the other. Yeah. So trigonometric questions always goes like this. So for this one now, we have what volume of oxygen, and they give you the volume of hydrogen. So they said gas, notes when they say gas, and notes. Okay, in this question now, okay, you can actually, like, before you calculate, you can actually bring out a reaction between your hydrogen gas and your oxygen gas. So hydrogen reacting with oxygen will actually give you H2O. So if you balance the equation, balancing the equation, it will actually give you 2 mole of hydrogen and 1 mole of oxygen. Yeah, so 2 mole of hydrogen needs 1 mole of oxygen to produce 2 mole of water. Yeah, so therefore, so for your calculation now, you now have, okay, let's move on to our whiteboard before doing this. Okay, so you are going to be leaving okay, so they said we remain. So for you to calculate the volume that remain, you have to first of all calculate the volume of oxygen, then before minusing this 20 centimeter from the answer you actually got. So from there now, let's move on to our whiteboard so you can actually see the solution better. Okay, on our whiteboard now, it said, okay, if you look at, we are actually looking for the volume of oxygen. So if 8 volume of hydrogen actually give you 8 centimeter of hydrogen gas. So the moment they said hydrogen gas, that is to say there's two, like the molecule of, that is the mole of hydrogen here, yeah, in this reaction actually like is 2. So you say 2. Then we are now looking for volume of hydrogen. Volume of hydrogen, that is to say the mole of hydrogen in the equation is 1. So if you do that, it will give you 2 times x, which is give you like crossing method I told you guys about, to be 8 equals to 2x. So dividing both sides by 2. So x will be equal to 4 centimeter of hydrogen. So they're asking you, sorry, of oxygen, yeah. So they're asking you to calculate the remain. So they already, like you in the question, you already have 20 centimeter cube. So, and okay, remain, so you can differentiate between the two, which is 20 centimeter minus 4. Yeah, so that actually give you, maybe they say remain or the difference. Yeah, so you can actually minus between that's your answer you got and the one they actually give you in the equation. So that should give you 16. Yeah. Yeah, okay, that should actually give you 16 centimeter D. Okay, that's why D is actually correct. Yeah, so you can see solution. All right, moving on to our next question. We actually have question number 15. It said, if one of the following oxide is heated with hydrogen or carbon using a Bose burner, okay, it is not reduced to the metal. Which one is it? Yeah. So if any of these like oxide is heated with hydrogen or carbon, they are telling you that it will not actually reduce to its metal, which just notice that in this question, a magnesium oxide is the most acidic or the most, let me say, ionic. Okay, this actually means that it is a metal oxide there. So magnesium cannot be obtained simply by reduction, but it can by electrolysis. Note it. And also note that metal can be obtained from highly ionic compounds through electrolysis and not reduction. Highly metals, if you look at your electrochemical series, you can see your potassium, calcium, but your like your metals that are not that high in that, okay, so those ones that can actually be prepared by what we call reduction. So your lead, your copper, your tin, so all those ones that can actually be reduced to their metal by oxidation or reduction. So I hope you got this question. So magnesium oxide is actually the correct answer. Yeah, because it's actually a high, like the most ionic or the most acidic metal in the question. All right, moving on to the next question. Okay, said A is actually incorrect. So lead can easily be obtained from lead oxide through reduction. Yeah. So notes lead can easily be obtained from lead oxide through reduction. B is the correct because highly ionic compound cannot easily be reduced. C is incorrect because copper oxide can easily be reduced. Yeah. So D is also incorrect because tin oxide can also be reduced to its metal, which is the tin metal. So okay, let's move on to question number 16. So in question number 16, okay, this actually requires us to like naming of compounds. So naming of compounds. So in this compound, you actually have, okay, you can write it down so we can move to our whiteboard and see how we can actually bring it to, okay, the first thing you need to do in naming compound, you have to form, like find the longest chain, like carbon. So in this carbon that they actually give us, so they just give us, so you need to find the longest chain of this carbon they actually gave. So finding the longest chain, you have to like rearrange it. That is to say, okay, CH3, the first CH3 to give you C, H here, H here, H here. Okay. Then the second one is CH2, H here, H here. The third one is CH, CH. And they actually give us a bracket CH3, then close bracket 2. So that 2 there is actually telling you that it actually have 2 CH3. So you can actually bring them down. So you can put, since there's no like other atom attached to this C, so you can bring one of the CH3 to this place and represent one here, which is CH3, or you can do it like this, C 1 2 3. Yeah, so note that there's H here, H here, H here, H here, H here. So for this question now, you now have to look for any substitutes in the question. So the substitute is this CH3, this one. Yeah. So to name this compound now, you have to like the longest, like count, yeah, you count it. So for this substitute, which is CH3, you have to count from the left to right and see and pick the lowest number. Yeah, so that is how you name. So from this one now, you have to count. Okay, you count it from the right. Have 1 2 3 4. Count it from the left, you have 1 2 3 4. So the lowest there, which is between 2 3 and 2, which one is the lowest? So 2 is actually the lowest, so you actually picked 2, which is 2 CH3 is what we call methyl, 2 methyl. And if you calculate the longest chain here, which is methyl ethyl propyl butane, to be 2 methyl butane. So that should be the answer, 2 methyl butane. So that should be the answer to the question. So C is actually the answer, yeah, which is C. Yeah. So I hope you got that. Okay, we actually look at more on naming compounds, organic compounds in. Okay, I'm going to give you guys organic chemistry so you can actually see more on naming organic compounds. So moving on to the next question, question number 17. So let's see how. It said, an aqueous solution of a metal salt M give a white precipitate with sodium hydroxide which dissolve in excess sodium hydroxide. So with aqueous ammonia. So the solution of M also give a white precipitate, so which dissolve in excess ammonia. Therefore, the cation is like in M is what? So note this question. This question is also like something you need to note down, because your zinc, your aluminum, and your lead, okay, because they actually give a white gaseous precipitate and soluble in SX sodium hydroxide solution, while only note that zinc, aluminium, and lead, they are actually like they give a white precipitate and they are actually soluble in excess sodium hydroxide, but only zinc is actually soluble in excess ammonia. Three of them are soluble in excess sodium hydroxide, but only zinc is actually soluble in excess ammonia. Yeah, this is a Jamb question. Jamb are always like they can give you in different phrases, but if you can know why that answer is actually the answer, so you can actually use it to answer any Jamb question. Yeah, so I hope you got that. So that is why A is actually the correct answer, which is so they're asking you that M actually dissolve in SX sodium hydroxide. So only zinc actually dissolve in excess sodium hydroxide. Yeah, I hope you got that. So moving on to the next question, question number 18. It said, what concentration of a solution containing 2 grams of sodium hydroxide in 100 centimeter cube of solution? So in this question, I told you guys concentration is equal to NV. Yeah. So, and in question like this, note that in this your question, you actually see something like the volume they actually gave you was which is 100 centimeter cube, but that of the volume they gave in the answer was DMQ, decimeter cube. So note in calculating things like this, note that one decimeter cube is actually equals to 1000 centimeter cube. So yeah, 1 decimeter cube is actually equal to 1000 centimeter cube. So moving on to the solution, we said molar concentration equals to the molar, molar, which is molar concentration equals to mass concentration all over the molar mass. Yeah. So if you want to do something like this, you can say, okay, the molar mass of which is the molar mass of sodium hydroxide, which is okay, sodium, we have your 23 plus your oxygen, which is 16, plus 1, which is hydrogen. Yeah, so everything will actually give us 40. So you already know that 1000 centimeter cube is equal to 1 decimeter cube. So like the cross multiplying method we actually did before. So if 1 dmq equal to 1000 centimeter cube, then 100 centimeter cube will now be equal to dmq. So you can cross multiply. So cross multiplying, like crossing method, it will now give you 1 times 100, then s times 1000. So s times 1000 will give you, so you now do collecting the coefficient of s, which is 1000. So that should give you 100 divided by 1000. Yeah, so that will give you 0.1. Yeah, so the molar concentration or the mass concentration equal to the mass all over volume. Yeah, like I told you guys before. So you can do it and it will actually give you 0.0, sorry, 0.50. Yeah, 0.50 is actually the answer, which is, you can see they actually give you 0.50, 0.05. You can see how Jamb is very, very tricky, but if you actually know your onion, yeah, I guess they can't be able to like confuse you in questions like this. So that's how you actually got that your answer. So I hope you got this. So okay, moving on to question number 19. Okay, question number 19. So it said, how many atoms are present in 6 grams of magnesium? How many grams are present in 6 grams of magnesium? So this question, okay, the Avogadro's constant, they actually gave you the relative molecular mass of magnesium, which is 24. Okay, note that the Avogadro constant is actually 6.02 times 10 raised to the power 23. Then the formula that actually connects this both, which is number of atom. If they say you should calculate for how many atom, or so you should know that the formula is number of atom equals to the number of mole times the Avogadro's constant. Yeah. So like doing everything there now, we should give you before then you don't have your mole, or they didn't give you mole in this question. So to get your mole, say mole is equals to gram all over, like the reacting mass all over the molar mass. So the reacting mass here is 6 grams. So the molar mass of magnesium is 24, yeah, 24 grams. So 6 all over 24 will give you 0.56. So sorry, 0.25 mole. Yeah. So 0.25 mole. So from there you can actually see the number of atoms in magnesium equal to 0.25 mole times the Avogadro's constant, which is, okay, they already gave you, which is in the question, which is actually 6.02 times 10 to the power 23. So everything there should give you 1.51 times 10 to the power 23. So that should be C. So C is actually the correct answer to this question. All right, moving on to the next question. It said, a radioisotope used in industrial radiography for rapid checking of faults in weld and casting. And when you just say welds and casting, note that it is actually combat. Yeah, so combat is the answer to this question. But let me give you the like other radioactive molecules or other isotopes or radioisotope molecules. So you have your carbon 14. Your carbon 14 is used in, like to find age specimens. That is age specimens, like probably someone died for like in, let me say, 10 years ago, or they want to do something like they want to find the what actually kills someone, or what actually, so things like age specimen in the laboratory. So you actually use your carbon 14. So the phosphorus 32, yeah, the phosphorus 32 is actually used to cure what we call the leukemia. Yeah, the leukemia is actually called the blood disorder. Yeah, so the combat, which is used for welding and casting, and that of your iodine 131 used for treating what we call the goiter. Yeah, so I hope you got this swollen of the neck religion. Yeah. So I hope you got this. So we are going to be stopping in question 20. So from question 20, we are going to be doing the third episode later on. So I hope you got value from this second episode. All right, don't forget to like, share, and subscribe to this channel if you want to get more video. All right, then, see you guys.